Good evening. Today is Dev Wednesday. Once again, got a new guest today. We're bringing on my boy Dan. Say hi, Dan.
Hello, everyone. How's everyone? Hope everyone's doing well this evening. I'm one of, you could call an apprentice of Eric. So I'm learning a lot. I'm still what we would call, I guess, a noob.
Yeah, it's all good.
Yeah.
But I wanted to bring Dan on. So, what happens a lot is that, I just may go over large details, and Dan's really good at kind of like helping me see what I may skip over and what's cool. Today, we're going to be doing something called Uniswapper. It doesn't exist yet, but we're going to make it exist today. We're going to I was on the internet and I saw the unofficial Python client created by a gentleman named by Shane Fontaine. Go out there if you're interested, make a few stars on his name. I think it's really cool what he did here. So he provided some sort of abstraction with Web3 to interact with Uniswap. The authors are in no way affiliated or funded by Uniswap, and neither are we. We just think it's cool, right?
Definitely.
Cool. So this functionality is like a simple to use Python wrapper for all available contract functions and variables. Simple parsing of data returned from the Uniswap contract. Run tests on a private chain other than Rinkeby. Better error handling. So it's kind of cool. Yeah. Have
Definitely.
you?
Yeah, I was just
Daniela is on. Hey, what's up, Daniela? What's up? It's on YouTube.
Great. Yeah, I
continue.
Yeah, no, I was just maybe suggest for our viewers who are not familiar with Uniswap, if you just give a brief overview of what Uniswap is.
Oh, Uniswap. I thought that's what you said.
Swap. Uniswap. I said swamp. That's embarrassing.
Okay. No, I'm embarrassing. All right. So Uniswap is a decentralized protocol for automated liquidity provision on Ethereum. Excellent. What does that actually mean? Let's go to the frequently asked questions. What is Uniswap? It's a protocol for exchanging ERC20s on Ethereum. It eliminates trusted intermediaries. Blah, blah. It's a decentralized exchange. So, like we have Binance, we have Bittrex, we have all these centralized exchanges. It's what we're used to if you have any experience in trading cryptocurrencies. And there's not necessarily wrong with them. I just think that people are looking for the true decentralized future that we're all kind of like shooting for. So one of the models that come with Uniswap is, not Uniswap, like a centralized one, like is custody. And then at no point does Uniswap ever have custody of your tokens. Well, they're sent, but custody is not absorbed by the contract. You either gain a token back from providing liquidity for the trades, which is the other end of, the reason why. So let's see what's liquidity. We actually have an entire stream dedicated to breaking down what Uniswap is. So I'm not going to go super in depth what that is, but the general mechanic is I want to buy a token, and we have a very simple interface here. Let's see. 1 second. So let's see. When you are using Uniswap, you basically are trying to swap one token for another. That's it. And that's like all people want to do. Because for one reason or another, you're interested inside of as for like a instrument for investment, or a programmer like me who wants to and just see what's up with a certain coin. Let's look at the interface. Do you see my screen?
Yes.
Okay, so it's very simple. You have Ethereum or your base currency here. You have, and then you have a select token. So here's another interesting. We can exchange it for an ERC20 version of Ethereum itself, which is funny. But yeah, it's interesting. So like a token can have a balance of Ethereum, or in its wallet a slew of ERC20s. So this one's a wrapped wet Ethereum. We have wrapped Bitcoin, wrapped DAI, and you can see you can actually change the list to what any projects that's out there. I don't really offer any investment advice. This is purely a technical review of software. There's love to give that little disclaimer there.
Always important.
Yeah.
Essential.
Essential. So let's just see. I have my VS Code here running, and I'm going to open it up. And I've called it Uniswapper. I have to get my MVM is all screwy right now. I don't know what's going on with it. But we can see here that we're going to 21 before the Savage. Let's go. Hey, what's up? That's good. We got some people in chat. Cool. So, first thing we're going to do. Do you know where we're going to start?
We talked about this a little earlier. Restful APIs.
Yeah. What is a Restful API? I don't even know what site this is, but Restful API is just a way for us to interact with it. We're not going to run it directly on. I want to build a tool that I can use with the front end, or make it so it's a tool that I can use. RESTful API is an architectural style for an application program interface, but we start with verbs like get, put, post, and delete. So if I'm asking for information, I'm doing a get. If I'm placing something that already exists, I'm putting, post as well, with creating new objects and deleting objects. Updating is the put, as it were. Refers to reading, updating, creating, deleting, blah, blah. So I don't like starting from the beginning. Okay. So what we're going to do is I found let's just Google real quick. What did I Google earlier? I was like, so we're going to be working Python. So we're going to be using Fast API. Yeah, that was what it was before. Cool. So we have Fast API. The one I selected today was one of the newer ones. Let's see. Supports Python 3.8, which is nice. And this is all about asynchronous programming with, so we can create WebSockets as well as classic get post requests. Docker image with a Uvicorn managed by Junicorn. High performance fast API web applications. For those who are asking what Uvicorn is that it is called Hypercorn, which is really no. I would think I'm at the very beginning. Quick start. Let's see, introduction. There's a lot of unicorns today. I was just thinking about that actually. So we're on Uvicorn. It's kind of cool looking. Lightning fast ASCII. So you would say, what is ASCII? And we're literally going to delve deep as what we're going through the tool set, and we're going to pop back out. How's that sound?
Sounds great.
Cool. So just so we know what we're doing here, asynchronous server gateway interface, a spiritual successor to WSGI, intended to provide standard interface between async capable Python web service frameworks and applications. In this case, we're building an API. Rip, come back.
Yeah. Just I guess at a high level, for those who don't know what an API is, just so you can have some context.
Yeah. Okay. So even this website right now if we go into the actual page and I inspect it, we can see on a network level, yeah, okay. So we got a whole bunch of really cool data that's coming in here. And you can see it's created by headers. It's got statuses, types, indicators. And you can see that these are GET requests. 33 requests to be specific in this page by itself. You say most of them are GET requests, and some of them are PNGs, some of them are HTML documents, just for this very web page. So just context that we usually, when you are creating or asking the web server, the browser to do anything, you're more than likely using a GET request to a server so you can see what's going on the website. That makes sense?
Absolutely.
So the server interface, that when you actually hit it and it becomes it actually allows it to spawn multiple instances of itself, so it can manage many servers, and just being able to have, let's see, achievable performance on par with, in many cases, superior to Node and Go. Interesting. High performance. Interesting. Runs asynchronous Python web code in a single process. Very excellent. So really what we care about here is the fast API library, modern high-performance web framework for building APIs, blah, blah, blah. So if anyone's used Docker, you can see that really all we need to do here is use this Tangelo UVcorn Junicorn Fast API, and we'll get everything inside of that. So if we look at it, Docker images, and we'll go back.
Just, I guess, at a high level, Docker, maybe you could explain to the audience.
Docker, excellent question. Now, here's another thing, is that we are looking to ship software. Oh, yeah, Daniel, this puts more unicorns in chat. It's a unicorn type day. I didn't even, but let's see. What's the best way to explain Docker real quick is that I think we asked earlier, what is a kernel?
Yes.
And a kernel is a computer program at the core of the computer's operating system. And we can use this web application right here. And you have your applications, they interact with the kernel that actually interact with CPU, memory, and devices. And that's for all, that's if it's Windows or if it's a Unix base, the kernel that is developed by, Linus Torvalds, for instance, for Linux. It's just constantly reworking and making that process of connecting to those things faster and better.
Got it. So it's kind of like the midway between the hardware and the software and applications, etc.
Yeah, and then we're in the red up here because we're developing an application right now that's going to use a combination of all my stuff, like network, the actual memory in my computer. And what Docker does is that usually I would go through it by hand and then install it. But we're going to do something that allows us to go much faster than just saying, oh, I'm going to install Python and I'm going to install or whatever. And that comes from the use of Docker Compose, where I can take multiple files. So let's see, we're going to create a new file here. We're going to call it just the Docker file. So whenever you start Docker, it places one of these inside of it. We're also going to make another file to orchestrate them together, Docker Compose. And that is stored in a YAML file. Yet another markup language. If you want to, YML stands for.
Markup. What is a markup language?
Markup language. So if we look at this website, we use lots of tags to describe and make things look different, but also where they live. So this HTML is a hypertext markup language.
Got it.
No problem. We'll go as deep as you want.
Yeah, for sure.
Let's see. So what a Docker file does, if we keep on looking at this, is that we can actually make a virtual, not a whole virtual machine, because usually virtual machines will copy the entire kernel, but Docker is really nice because it'll be faster, use the pre-existing kernel, and then treat it like another virtual environment inside of it, which is really tight. Let's see. Let's see. So if you think about it, if we're spinning up a new instance, we're doing things over and over and over again. And what that we are doing over and over again, if you look at here, we are from D'Angelo, Unicorn, Junicorn Fast API at Python 3.7. We're going to bring that down, download it, unpack it, copy the requirements.txt, which we're going to write in a second, into the file system, install those requirements, and that's just kind of like an idiom that all Python people use. Copy all the contents of the app folder into the local app folder relative to where we are, and then to the root of the folder. And then we're going to expose a port here, because at the end of the day, they're going to be running memory, and then we're going to be able to access them over the network. So this one is 5, 6, 7, 8. So I believe if you want to actually know what that's going to do, is that we're going to be able to debug our Python instance through that port.
Got it.
Cool. I wanted to make another. So since we're asking for it, might as well create our requirements.txt. And there are two libraries we're going to use today. And what I was just mentioned before on 5, 6, 7, 8, we're going to run a Python debugger. And that's going to be available to us, PTVSD. Another, just basically as we run our API, that we can stop it and break it at any point, which is neat. And Uniswap Python, which is exactly what we have over here when we were reading about it. So, when the author here, Shane, told us to install it, pip install Uniswap Python, or pip install, I believe this is the GitHub egg for it, so you can do it directly from GitHub, which is great. We do that. So when this Docker container spins up, it'll download it and from over here install it. So you remember from our Docker thing, it'll actually copy that text file in there and then run pip install. So we are following the instructions, but in our own little way. Docker allows us to restart the container if things go wrong. There's a whole bunch of other benefits when sharing and getting the code from someone else. It's pretty nice.
Nice.
So, Docker Compose. I have one prepared here, all cooking show style. We're going to be using version 3, and we'll call this Uniswapper. So the build file is relative to the first file that we're in, the place where everything lives. You see that? Remember see how these things are doubling up? There's always seems to be a dichotomy happening, is because it's always referencing what's happening inside the container and what's inside of the container.
Okay.
So it looks to me that the volumes in which all the things are going to be stored on are in our /app folder, which you remember from our other Docker file have been already copied over. And you can change the ports. So if this was port 8080, which I have here, I could change it to something else on the way out. But I'm going to keep it pretty much the same on each one. There's that debugger 5, 6, 7, 8, and our port 8080. I'm going to create another thing here called an environment variable file. So we can store all of our sensitive information in it.
Great. Could you maybe talk a little bit about with the ports, the functionality of the ports?
Well, port 8080 is a classic internet port. So usually what we don't say when we go visit any website is that we're getting it usually from port 80. And right before it hits the internet, we use something called a port forwarder. So, and maybe initially our API will be written in port 8080, but we'll have another computer program like Nginx or Apache to forward another port. So it'll take in that and be the safe gateway to the outside world. You feel me?
Yeah.
Because that's the weak point for hackers. People doing a distributed denial of service attack. All these different things. These are where it lives and where the action happens. That's the door in which we open when we go to a website.
Okay, so is it like a kind of like a translator, so that like the program could compile or something, or?
No, I think it's more. I would say it's more of a router.
Router, okay.
Like someone who's just going to direct the traffic, like a police officer in the middle of a road.
Got it.
So let's see. I'm going to create a new file here as well called development.env. We're going to store all of our environment variables in here as well. We'll get to that later, but that's what they'll live in there. I think that it'll run right now with no code whatsoever, actually. So if I say, let's look inside, say docker compose up, we'll take it all. Class none type. Top level object in docker compose needs an object to be not class none. Interesting. It says it's there. Aha. Oh, I might have things running on already. It seems I already have something running on it. So I'll say docker stop. Make sure that stops. I think I have like an old instance of it running.
Huh.
Okay, cool. It's running, but it's looking for import string app inside of model, but we don't have anything running, so that's good. So that's good that that's running. Get rid of that, put it aside. Very cool. There's nothing in our app. Let's we're going to create a new file called main.py inside of our app file here. Guess what? That will contain all the main functionality. Access permission denied. What you mean? Weird. It's weird it's doing that now and that wasn't doing that before.
Huh.
Interesting. don't like that one bit. Okay, so we're going to get stuff from the operating system because we're going to use some of those environment variables. We're going to bring that in here. We use JSON, import logging, so we can actually log stuff out to the console. From Fast API, we're going to be using the actual Fast API response status.
Are those just parameters for?
Not parameters. I would say different aspects of the library that we're going to.
Different aspects of the library. Yeah. Okay.
So, yeah, I don't think we're going to use JSON response right now. But response is like actually, like remember when I showed the inspect on the page, it was when I asked for the website, I got a response back saying 200 okay. I would get stuff like, you ever get a 404 error?
Yeah.
Okay, that means that's not found. There's lots of these little codes that we share. So whether or not, that's the idea behind the RESTful thought process is, it doesn't matter if you're using Java, Python, Go, we're going to make an API. These are status codes that we all can agree on.
Got it. Yeah, I see right now it says from Fast API that import. Okay, got it. I've never used Python, so
we're good.
Yeah.
This is the debugger that we're going to. We're going to go from the top, and then we have Web3 itself. So Web3 is popularized because of its ability to work with Infura, Ethereum's service for creating using I think I'm going to use the development environment and variables, and I'm going to keep it off to the side of the screen just so I can import some very important yet sensitive aspects of what we do here, which is private keys. So what this will do is that we can use our private key stored on our computer to actually take the public key, make a signature, and have a transaction happen, which is pretty tight.
Got it. Yeah, I was just wondering, maybe it might be a good idea just at a high level explain a little bit just about what Web3 does and the library. And
I think that's as high level as I can get. It's that it's the actual piece of software that Python will use to talk to the Ethereum blockchain, which is like the star of the show today. And Uniswap is on there. So anything that we need dealing with that, we're going to use it. Yo, thanks everybody. I can see people are coming in the chat. What's up?
Hello, everyone.
Welcome to the stream. We are developing an API for Python to interact with the Ethereum blockchain and Uniswap. We're developing a little app called Uniswapper. So let's look at it. I took directly from the last page how to use this class. So right here, we have Uniswap stuff. From Uniswap, import actual Uniswap. And then when you instantiate it in Uniswap wrapper is equal to Uniswap, we have to pass it some information in order to, actually to instantiate it. But if you're talking about Ethereum itself, it is talking directly to the Genesis address we have right here, the beginning 0 address. I think this is the contract address for BAT. This is the contract address for DAI, stablecoin. So if you were to use it, which we are about to, we have to, on the constructor of this, the dunder init, the magic method, something happens when you create it. It desires an address, which is going to be a string and an address. We have a private key, a provider with the actual route that we're going to use to provide it. You can use an Ethereum node that's living on your computer, or Infura, which we're going to use. Web3 instance. It can be none. There are multiple versions of Uniswap. I believe in our other stream, we denoted what the versions differences are. We're in version 2 at the moment. So we can see our version is default 1, which we're not going to do. And something that we talked about earlier, Dan, slippage.
Slippage.
Yeah, what is slippage?
So slippage is basically the variance of the price executed during a given transaction and how those that order is fulfilled.
Mm-hmm.
So yeah, but if you could go ahead and maybe explain in your words, I'm sure you have a much.
That's it. That's it. Nailed it.
Nice.
Done.
Cool. Yeah, because I know that was something that was a mystery to me too. I was wondering, had asked one of our guys, like, hey, when I was starting Uniswap, what exactly is slippage and how is it relevant? So, I think that's useful information for anyone watching who hasn't used Uniswap. So,
cool.
Yeah.
So, once you have that cooking show style, bam. Now, it's interesting. I didn't actually have to show my private key on stream because I'm using an environment variable here. I mean, who knows? Maybe I'll flash it by the end of the night. That would be really unfortunate, I guess. But, that'd be so. Really, you can see is that we're going to have a development environment variable. Let me see if I can pull up my other environment variable without showing my keys. Hold on. Let's see.
Give me your keys.
Give me your keys. And my Infura provider. Let me hide it real quick. Project ID. Okay. All right. So this is our dev environment. We can see that we can just address it as provider. So you can see I said nope, and your project ID, you can go off on your own and get an Infura account. That's nice because it'll allow you to basically have this. If you don't have the ability to run your own Ethereum node, which is about a terabyte, then you can run this Infura instance. You get your own API. It's not really an API key per se, but it's a project ID. You get infinite usage, I feel, because it's usually you're not using a lot. You're just querying it a couple of times. So the Ethereum Foundation allows that to be run. You can see I have a couple of preloaded contracts here. I wanted to add a feature here that would go out into like Etherscan or gasstation.now and like pick up all the most gas guzzling Ethereum contracts out there to see if they can be traded upon. Thought that would be neat. But right now, all I care about is Ethereum, WETH, BAT, DAI, ZAP, Uniswap, Coin Uni, and USDT. I'm just going to use those for at the moment because it's cool. So you can see that's where that would live. I want to close that out. And it lives here. Actually, I'm going to put my real environment in there real quick off screen just so it can work. Great. So it'll actually take in that address, the private key, the provider. We don't have it pull in a custom Web3 instance, just none is here. We want version 2. You can see that's 1 to right here. And the max slippage is going to be a floating point, making sure that it takes in that string and returns a floating point integer here. So it's going to be 0.1, I believe. Save.
Right.
Why do I have no access to this? This is kind of a quandary. Maybe that'll help. Man. File system error. That's so bad. Why? One second. Let's find out what's going on here. Wonder why that happens. So weird. Does that save? Oh my gosh.
Huh. Failed to save.
That's so weird.
Yeah, I've never run across that.
No, well, that happens because, like, for some reason, I don't have privileges to do that.
Oh, I see.
That's odd. Let me think real off the top of my head how I can fix this. Because it's going to be a pain in the ass if that doesn't work.
Huh.
Let's see. Copy all this, close this one. Don't save.
Oh man.
That's fine. Why? Unable to write it. What is going on here? This has literally never happened before on air. Wow. Let's Google this real quick. On failed to save. Save. What does it say? Unable to write. Unable to write. File US code. What does this say to do? Logged in. Okay, let's try it. That's making me super mad.
Damn.
Let's try this again. All right, it worked. Great.
Nice.
And that's using WSL2 on Windows. Windows just give you some random problems. Okay, yeah. So moving on, we're going to enable debugging. So we're going to, from that environment variable, if it's not production, then we're going to, I don't think we have an environment variable set for environment. So it's never going to be prod. So it'll always involve the PTVSD. It's going to enable to us attach, which will allow us to run this little guy right here, the debug things.
So it says enable. Okay.
Just want to say hi to new people who just joined. Hello. We're right in the middle of like doing, I just recovered from almost a stream ending problem. All right.
Superposition made the.
Yeah, we're back. So
great.
let's see. What it was before it was looking for was app is equal to fast API. And the actual like instantiation of it. That's what the problem was before. Okay. Well, let's see. Let's get some ASCII art in here. Do you know what ASCII art is?
I have no idea.
Sweet. So days of old really have like GUIs. So all command line stuff, but we can type something neat. So we'll call it Uniswapper. See how I typed that in?
Yeah.
It's neat.
Yeah.
Long day, huh?
Yeah, yeah. Previous stream got me a little tired.
Excellent. Well, we're not going to go until this is done. Prepare.
Nice. I'm ready. I'm strapped.
So Uniswapper, let's just tell me when you like something. We have money signs. That's cool. Like that one's kind of like a 3D-ish look. That one's kind of hard to read. It's like little people.
Yeah. Well, that's like an old 80s metal song.
Yeah, it's, I mean, this is awesome 80s type deal, you know?
Yeah.
It's like some 70s type stuff, to be honest. Uniswapper.
Uniswapper. You can't even understand that one. That's that. I like that one. That one's
this one?
Yeah.
Yeah. It's big as fuck.
Well, yeah, let's just try something a little smaller. Yeah, maybe, yeah, it's a little, on second thought. You can, that's, that go back. That one's not that bad.
Right,
but
it's called Epic. We'll come back to it.
Yeah, sure.
It's on fire. Can't really read that.
Can't
really read that. No. It's kind of neat. Yeah.
Those were, we passed by a couple new ones, I think. Uniswapper, that one's. That one's nice.
All right, we won.
Yeah, I like that one. Uniswapper. A little hard to understand. No, the S is a little.
Yeah. You want to keep going or what? Let's make a quick.
Yeah. Let's see what's up.
Daniel says yes.
Yes,
the what?
Little
twisted. We got wet letters. Ooh. Uniswapper.
It looks like a Uniwhopper.
Uniwhopper.
Uniswapper. That was cool, but it's a little hard to. Uniswapper. All right, I mean, that one's.
All right, this one's. I'm sold on this boy.
Yeah, I like that.
It's very legible.
Like that. Yeah, definitely.
Daniela says yes, but I don't know to what. So we can do a string literal here. Then we'll do 3 in a row, and I'm just gonna be like, well, bam.
Bam. Uniswapper.
Cool. So when we actually run the program, I'll have it. I'll put it. So up here we have logging, so we can actually log the output.
Mm-hmm.
I'm going to say logger is equal to logging.log.get logger. Yeah. And we'll say dunder name for you're starting to see me using lots of these like maybe arcane or cryptic dunder and init, I call them, because they both have these dunder double underscores here.
Uh-huh.
But it's like a insight into the way that the file system, the data model for Python works.
Huh.
So like if there's a equal sign, there's a dunder EQ, and if something there's a plus sign, then there's a dunder add.
Yeah, dunder. What exactly is dunder? Is it just like
double underscore?
Oh, got it.
Got it. So we're just calling these the magic methods.
We
saw one up here for the instantiation of an object, dunder init.
Yeah.
So when you hear me say dunder, it's a magic method. It's magic.
Magic, like Magic Man.
Yeah, it's only magic because yes to the biggest letters on sticky, tongue face. Okay. Cool. Blah blah logger.info, and info is different from like error or warning. You usually have one, so we'll call this so that we'll just log out that Uniswapper. It's kind of toy. So let's just. We're actually coming up on 45 minutes here. It's pretty tight. So we're gonna make a post, and we're gonna ask to swap the asset. That's gonna be the coup de grace. But a little easier to program is get asset value. What the heck? In USDT. Another one I have planned for is, let's see. Well, an easy one, getting the token balance. Now this is all stored on the Ethereum blockchain. So that's when you say this is a back-end application or database, it's just really, really, really expensive and distributed database, which is called Ethereum. It's a database that you have to pay.
Yeah. A significant amount now.
Yes. Unfortunate.
Yeah, that gasoline will be adding up, man.
Okay, so I'm gonna use a decorator to wrap. I think we're gonna say, let's do get token balance first. So we'll say get. Let's say token balance, and we'll use a format string. I'll call that asset. Be nice and generic.
Nice.
Now we'll make def token balance. We'll asset. We're going to make sure that it's type safe. So it's going to be a string. And if no one pulls anything inside of this, it's going to be none. Now let's see. So that's like, the actual when we hit the endpoint, that's what we'll have. Okay, we're going to encapsulate this inside of a try except. This is important for us to capture if something actually has something wrong with it. So if something bad happens, something goes wrong, then we'll say return. And here's that response that I had earlier. Response. We'll bring status code. And if something goes wrong, 500's internal error. Let me just put 404 for now. It's probably not the right code for, but I can hear in my ears Michelle Obama is going to have her own podcast on Spotify. Interesting. So I'm going to be using JSON. I'm going to say something went wrong.
Dumps method. What does that do?
Dump string. So we're going to take this dictionary and we're going to turn it into a JSON statement.
Got it.
Very, very, very simple. Okay.
Wow, something went wrong. Error.
I think we're getting all this error ups here because I didn't. So I have this pre-coded response. Since I wanted to get the token balance, and we're going to say, ooh, unexpected. Come back to that. Why are you wrong? I don't want to figure out right now. But this is where we actually start using the environment variable.
Okay.
I'm going to start using a little bit more code here. Let's check it out. Okay. Happy little functions. So I created a thing called checksum. So we're going to take in the asset. Maybe what I've been looking at and trading a lot is Uniswap's native liquidity currency called Uni. Very cool project. Not project, I mean cool idea for it, because that's to offer liquidity on both sides. They created a token. Very interesting, but right here we have to convert it to an address that is digestible. So we have that asset living inside of our environment variable. So if it's Uniswap, remember from our previous iteration that we have the Uniswap's contract address there. So the UNI will return that entire address as a key inside of this environment variable. It'll go through. It's wrapped by Web3 to checksum address. We'll take that checksum address.
Okay.
And then we're going to, the balance that we actually care about. The balance that we actually care about. And let's pull up that website one more time. Looking for balance here, right? Get token balance. So you can see that's our usage of it. BAT here in this case is the environment variable. So we'll actually get the balance of, but you can see right here, checksum is there. So we're actually going to get the balance from my own balance and not from a foreign balance. Don't be yawning that mic. You're going to make me.
My bad. I didn't know you could hear that.
I can hear it super clear.
I'm sorry. I'll be sure to mute myself next time.
Oh, my nose is itching. Oh, my goodness.
Yeah, man.
It's going crazy. Ooh. Maybe I'll do a standard response. Let's see if this will fall. All right, cool. I think I'm going to sneeze. Oh, my goodness.
Oh, man. It's all because of my yawning.
Nope. Yeah, I'm falling apart. You tilted me. Yeah, it's fine.
Cursed.
Hey, no. You know, we're running up to an hour already, and we're already just getting to one function. And I want to see if we can get to that one place, and we'll start. So let's see if we can actually get this to run. Let's just see.
Whoa.
Run Docker Compose build because we changed some files in there. Run install requirements. Make sure that everything is installed before we go in there. Aha! Everything wasn't installed. So I used Docker Compose build to make sure that everything inside was built up.
Okay.
Seems to be that was not the case. So we just going to install all of our pip install requirements from Docker Hub. I think I'm out of water. Damn.
Yeah, I'm out of water too. I'm a little depressed about that.
I know, but go get me water.
Yeah, seriously. BRB, bro.
No, I got one in another container.
Oh, man.
Ha.
Yeah, that's
very good. Okay, building the wheel. Bum, 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 bum. Here we go. This is the thrilling part. But that kind of, this does solve the issue of it doesn't run on my computer because sure as hell should if you have Docker installed. Cool. So it looks like everything installed. Figure it out. Cool. We'll say Docker compose up. And let's see if we can get it to run. Aha! So that's kind of why I wanted Uniswapper to appear, because you get that really satisfying Uniswapper.
There we go.
So you can see I have my project ID. It's connected to the mainnet and Infura. Got a response back. Even using the factory contract. Excellent. So we have Uniswapper ready to go.
Nice.
And we have something. Now, it's a play on words, but we have a REST client called Insomnia. So that's kind of like a funny play on words.
Yeah. Mm-hmm. So yeah, I remember earlier you told me that the functions communicate with Insomnia and they get an API call, and that's how.
Yeah. Okay. So One of the calls that we can do here is called docs. I don't know. It's supposed to be a feature of Fast API. It doesn't seem to be running properly. Either way. So we're like, that's what I was just talking to you about before. I have this actual web server here. So you can see when I was, even if I was getting an unknown error, it was still getting these GET requests. You can see them flooding in right here, correct?
Yes. Yes. Get.
Get. And it was just wrong. I could type in something in here and we don't even know what that is. So we get a 404 error. Yeah, 404. Wow, 404. And to be specific, we were creating resources here. Hey, even more people have been joining. Oh, what's going on?
Hello, everyone.
Don't feel any type of way, but to spam chat.
Yeah.
Okay, so let's see. So we have Uni here in our payload. Not the payload necessarily. It's right here in the request. So if we hit detail, Uni not found. Interesting. So now we actually all of it. We're going to do everything at the same time. So we're going to debug why that is happening. So we can use our little red dot here.
Okay.
Go back in here. Create a JSON. Launch.json. I have one prepared here. It's going to do a remote attach. So it's going to be running on, here's that port again, 5678, local host. Here's our app, wherever the workspace folder is of our IDE, which is this. We're going to save it. But we're going to hit play. The color change shows that we are connected.
Nice.
So I want to hit the breakpoint on line 73 here. And we're going to bring up Insomnia to actually launch that again. Oh, that's why. Because we're not even typing it right. Get bounce. Token bounce. Cool.
Nice.
So you see when I ran that, you can see inside of our debugger up here, this is exactly what came in. Asset is Uni.
Mm-hmm.
And we can hit play, which would allow it to continue, or we can step over our functions. And as we go through it, you can see that the checksum returned an actual address that we can go look for. So Uni's address starts with 1F98 and ends with 5984. Its balance is 0 right now. We don't have any Uni. Unfortunate.
Yeah. I wish I had. I had some Uni about a couple weeks ago.
Yeah. So okay, it ran out. But if we go back here, this is the magic right here. This is so like if you were, when you say you're full stack, if you have this JavaScript library that would take that input and then make it look pretty on the front end. But as a back end, we are really, I have 0 Uni right now. You can see it looks good. So actually, just put a $sign there, save it, come back around, take our breakpoint off, just hit. There you go. I got a little $sign. Balance of Uni in dollars. Maybe it isn't dollars. I don't think it's dollars. I think it's just the amount of Uni. Cool. Done. So you can see we went from start to beginning to use Uniswap's wrapper to get the token balance.
Uh-huh.
We're already like at an hour, so let's just do one more. And I think that would be really good. And we can continue. Let's get the assets value in USD.
Nice.
We'll work on the actual swapper at a later date. Man, talking sure as drag it out.
Oh yeah.
All right. Cool. So I have here app get asset to USDT, which is the token for USD. We're going to call it reiterate, but we'll call it to USDT. That'd be nice. So we take in the asset. It's a string, and it's none if there's none. But we're also going to create two variables right now here, rate and USD rate, which are going to be floating point. Now, I was doing this earlier, so really, like, there's multiple things happening here. There's prices of Ethereum, there's prices of Uni, and then there's the rate between all of those, and we want to end up at USDT. So I actually set it up here. We want to get USDT, so we're going to do some unit cancellation. So if we have asset, if I have one in this asset, then I have asset that's already inside of the numerator, and Ethereum's going to be, so when I actually run that method, I'm getting the asset towards Ethereum against Ethereum. And I'm also know that I'm going to get the asset of USDT against Ethereum. So if I want to cancel that unit out, I have to invert. So if I say 1 divided by the asset divided by Ethereum, Ethereum actually pops out on top. And the inverse value will be useful for us. So because Ethereum's price, or at least its unit, is going to be inside the denominator. And then if you cancel them all out, you'll have USDT. So asset will cancel out, Ethereum will cancel out, and we'll just get USDT. Right, Daniel?
I've been talking the whole time. My mic was muted.
Oh!
Yes, yeah. It is what it is.
Oh, you know that's the actual newbie move.
Yeah, for sure. Yeah.
That's what happened to Lil Durk actually recently when he was on Ninja stream. Ninja, like, he was streaming on Twitch, and then Ninja hosted him, and his mic was muted the entire time. And then
Wow.
Thousands of people come to your stream and they hear nothing, so they just leave.
I mean, no one checked on him. Like, hey, bro, is your mic?
Hey, I'm not a producer for Lil Durk. I don't know. You know?
Yeah, because I know that happens to us sometimes. I think like earlier today too. Like, you know, or the other day, you know, we were all talking, and you know, I was talking. And you were like, You said, Daniel, you're being kind of quiet. You know, and I'm like, oh, because I was muted. You know, I don't know if you remember that. But,
I do. No, I do.
Yeah.
You just gotta. You know, I feel like we're on a conference call, but with the future.
Yeah.
That's
For sure. I'm just here trying to balance like outside noise, my house, my dog's barking, and all that stuff. So I'm trying to, you know, keep it a quality stream. So
quality,
yeah.
Okay, so I was playing Among Us with some UK EU people. So I've just started to talk like this. Quite suspect.
Quite saucy, yeah.
Quite suspect. Have you played Among Us yet?
No, I have not.
Oh my god, you can get it for free on iOS and Android. So, and you're already on Discord, so you can get on some sweaty lobbies.
Sweaty lobbies.
Yeah, like these kids actually get into it. Like it's like all about like lying to your friends, basically, and like who's the imposter, you know, and they kill everybody on board.
Nice.
You kind of like have to vote them off, and then like throw them out of the chamber. It's pretty sick.
Okay, yeah, I've played a similar game. It's called like I think like Werewolf or something. Someone had to. It's similar to that. Like
Sure.
yeah, I don't know if you've ever played that game, but
It's a
yeah.
tabletop. It's a tabletop.
Tabletop. What is that?
A game you play on the table.
Oh yeah, yes, it is. It's basically the same thing. Yeah, people basically lie about them being a werewolf or not, and they say, "Oh no, I'm just an innocent villager." And then at the end, you have to like choose who to kill, and sometimes you kill a villager, and then you won't kill the werewolf until it eats you. So
Yeah, but you can vote them off. But the other way is that you can complete your tasks and then win that way.
got it.
Okay, so let's just finish this
Sure.
cool little feature off, and then we'll end this stream. But so we have to get the rate, which is the asset over ETH, and then we get the USD rate, and that's USDT over ETH, and then we can. It takes two functions: the checksum, so we actually get the checksum library, not library, address of Uniswap, or if that's what Uni is the actual asset that came in. Maybe it's just plain old Ethereum. Checksum against the USDT. So I actually just hard coded that in because F it, YOLO. And you can see that it's right there. Ba-bam, wa-bam. So we're going to get the rate from the Ethereum blockchain. Yes. No, but that's what's interesting is that it's our units of measurement are in a gigaway, or 10 times, or whatever, times 10 to the 18th power. So many zeros are usually inside of or how fungible that these tokens can be.
Damn.
Yeah, so like I think it's like 16 decimal places for Bitcoin, and that's measured in Satoshis.
Yeah.
Correct. So this is our way, or how pennies, or there's many different ways of expressing it. Interesting. So for my next act, we have here comes the magic. Magic. So we actually encoded it in Python. So here's our actual calculation. 1 over the conversion of the asset over ETH times the rate of USDT to ETH will yield dollars.
Got it.
So conversion, now you can see right here, I used my PEMDAS, and I wanted this to happen last, so I excluded it from the parentheses, made a smaller parentheses, and then made an even different parentheses. So I knew that I did the inversion first, and then the rate times 10 to the 6 for the actual rate in USD, and then times GUI. So actually, it's because I don't want all of the units. So I'm just going to take that, and I get the units from the asset directly. So I don't know what it is. In this case, we're probably going to use Uni. So it will be Uni over USD, but it can be anything because that's what format means.
Yeah.
These brackets.
Okay.
So it's going to create a string, whatever is the name of Uni over USD, blah, blah. And here comes that really cool response that we had. We're going to return this response to our API. And so you can see we're going to return a status code of 200, successful, okay. The content is going to be a JSON object from a Python dictionary. And that dictionary is going to have that unit we just created, well, bam. And we're going to express it in dollars. So we're going to take we're going to format the string, all of the string. So there's no, we actually can take, I think we're going to use just like cents. We're going to lob off out of 18. We're going to keep 2 for cents.
Got it.
And then this is hard coded because it's never going to change Ethereum to USDT. Crikey. Then we're going to use the conversion rate and get that. So let's see if that will. Let's go from the hip. See if that will work.
Bam.
So Uni to USDT. Unexpected indentation error. Okay. This is the fun part. We don't know why it's broken. Unexpected indentation. Why are you saying that? Did I not close it somewhere else? I don't think we closed it all the way. Maybe that's the issue. For token balance, that means that I didn't close this completely.
Okay.
Probably should just have some bullshit accept statement real quick. Oops. 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 Invalid syntax. Now that's where we know we messed up somewhere. Invalid syntax. What you mean? Okay, so I think that's the issue. So we're all out of indent. Here you go. It's very important. We don't have brackets in Python. It's kind of so we have to keep everything at the correct level of indentation. So you can see I have 2 indents here.
Yeah.
Try is going to take care of all the code inside of this indentation, and accept will as well. Seems like it's working now. Let's try it again. Aha! So right now, Uni to USDT is $4.60.
Nice.
And ETH is USDT. Now, this is excellent. We're way over time. So we can continue to work on this probably in another live stream, or I'll post the code and you can see actually us implementing the actual swap aspect of this. But I think we covered a lot going into this. There's a lot of concepts here.
Yeah,
that were we learned about Docker Compose and how we can spin up these instances. We learned about REST APIs, how to create them from scratch. How to rebuild Docker Compose files once you have new information. So you can see it. Build. We figured out what asynchronous server gateway interfaces are. We learned about Infura. We learned about environment variables. We learned about a bunch of stuff. We learned about how to actually interact with Uniswap's contract via a very convenient Python wrapper. We learned about error catching and responses and all of that jazz. It's pretty tight.
Tight.
How did you feel? Did you think you felt you learned something today? It was interesting.
Yeah, definitely. I like to, this is, I guess, another way of, the advanced, I guess, end of trading,
Yeah, because you know what's going to happen is that we develop these because we want to have something that goes faster than we can go click something.
Yeah.
It'll save our wallets. Now, me and my friends can use a tool so we can actually launch trades or not launch trades and just see analytics live. So if the website doesn't actually refresh fast enough, this is a quick function for us to see, okay, cool. That's 2 cents more now since it was before. Really neat. So we'll actually be like quickly be able to do that, and you can see it on the bottom. We also learned how to debug, which is tight.
Yeah.
That's my TED Talk here.
TED Talk. You seem to have a TED Talk at least a couple times a week.
Hey. This is tight graphic too.
Oh, yeah.
So thank you everyone for attending. We went over our time, but I'm not going to be worried about that. It's pretty tight.
Definitely.
Thank you for staying up with me, Dan. I hope I didn't bore you.
Of course, no, definitely not. I'm happy to join. And yeah, exactly. Thanks for everyone that showed up, and
And shout out to my boy Shane for writing the library. Give him a couple stars. Buy him a cup of coffee. I don't know.
Yep. That's a pretty cool graphic.
It's pretty tight.
Yeah. Put on Shelby. Look, put a little unicorn instead of a cool.
I know. There's a lot of unicorns today.
Yeah. Yeah. Pretty soon we're gonna start swapping unicorns. Actually unicorns. Hey, maybe unicorn NFTs, guys. Let's make it big.
Yeah, but hey, thank you for watching the stream. I'm Eric and Dan from the Blockchain Center. Dev Wednesdays. We're signing off. We salute you.
See you guys. Have a good one. Hope everyone has a good night. Thank you, Eric.
No problem. Thank you, everybody.
Thank you.
Goodbye.